Hello, today our team will be making a problem about solving oblique triangles. This is the problem.
A person is located at point A on the ground, observes the angle of elevation to the top of the water tower to be 25 degrees. He then walks 110 feet towards the tower to point B and measures the angle of elevation to be 38 degrees. Points A and B are on the same side of the tower. What is the distance from point B to the top of the tower and the height of the tower? In order to solve our missing sides, we must try and complete the triangles with as much of the data that has been given to us. As you can see, we were given at least three triangles, in which by understanding the characteristics of angles we can complete the missing angles for the missing triangles. For example, the angle B forms a straight line. Each straight line is 180 degrees, therefore if we subtract 38 from 180 degrees, we obtain 142. Then we know that each triangle has 180 degrees, so we can complete the information as follows.
So now I will be explaining law of sines. So law of sines, the basic formula for everything will be... So what you need for this to work, for law of sines to work, is a pair. So you need an angle and a side that is from the same. Well, you need the angle of A and the side of A for this to work. And you also need one of these as well, so you need another side or another angle. So now it's time for law of cosines, and for law of cosines you have two bases for every formula, and one is to get the angles and one is to get the sides. So to get the angle with law of cosines will be the following formula. So we have here to get the angle of A, but you can also just switch this around to get other angles. So you can also do this for the C, and it will be basically how to get the angles. So how you use this is when you have the three sides but no angles. So to get the sides, same as before, it's one formula, and from that formula you can do the other ones. So it's a squared, which this will be the side you want to get, is equals to so this you will use it when the only thing you don't have is the side you want to get. And to get the other formulas like this squared, so like before, this can be solved really easy. So you just need the angle, the side of A, side of C, side of A, side of C, and the angle of B. You just put everything, all of this in the calculator, and then you square it, and that will be the answer.
Now that we have found all the missing angles and we already learned how to use the different formulas, we're gonna use it to find the missing sides, or the ones that they specifically told us for. So in order to do this, we already have like one side here. So what we can find first is find this side, which will be the hypotenuse of this triangle if you divide it into two triangles. So for example, we can use in here, for example, law of sines. Law of sines, as said before, it's just using the opposite sides and then finding the equal, so the ratio per se. So if we have 110 feet, we're gonna use this one, the opposite, it's angle 13, so it will be sin of 13. This is equal to, for example, we have already the angle of A, which is sin of 25, and the missing side that we're trying to find, which is x. So in order to do this, we're just gonna take like this. It gives us this side, which is equal to 206 206.65. Now that we have the missing side, which is 206.65, we can either use here law of sines or SOHCAHTOA. In order to use law of sines, we could just do the same as before.
We found that sin 90, which is the side that we already have here, is 206.65 is equal to, for example, the side that we're trying to find over here, which is sin 38. If we're trying to find the y, we again just put it in a calculator, take this, pass it over here.
127.13. And that's how to find the problem. Well, now that we have found the missing sides, the problem asked us which is the height of the tower, which was our y, the height is 127.22, and the distance from B to the top of the water tower, which is 206.65 feet. Law of sines, law of cosines, and trigonometric radius are used in the daily world for every single type of use, especially in things such as architecture or structural engineering, especially structural engineering, since it involves a lot of triangles.
So by doing this project, I was able to learn a lot, especially since this problem really helped me a lot to visualize it, since I didn't thought before how we can use this in real life scenarios, like measuring something really high, and this really put into perspective since we needed to explain in detail. And this helped me realize that solving these kind of things with these formulas and everything can really be applied to everyday stuff. And my contribution to this project was explaining basically how we can use SOHCAHTOA and law of sines and law of cosines to basically solve these problems.
This project helped me a lot in order to see in which real-life examples these kind of formulas and such can be used. For example, there's different jobs that use this in a daily basis, and it's all around us, especially triangles, since it helps a lot when in structures. So it's very important that these have the right measurements and such. What I contribute to this video is that I explained the problem itself and tried to apply the different formulas that we learned in order to find the solution.
In class, I was having a lot of trouble making this type of problems, but since now I explained it like if I was a teacher, now I really understand it 100%. And also with my classmates' instructions, I helped myself into understanding this topic. I also understood how to take a problem and apply it to a real life issue or problem.